Welcome to Beyond the Brackets. Let's understand Poisson distribution through a few problems. The first question reads as follows. If the probability that an individual suffers a bad reaction from a certain injection is 0.001, find the probability that out of 2000 individuals, exactly 3, more than 2, none, and more than 1 individual suffer a bad reaction. Here, total number of individuals considered n is equal to 2000. Since we are finding the probability of individuals suffering a bad reaction, that will be considered as a success p, which is given as 0.001. We know that for Poisson distribution, lambda is equal to np. Substituting the values of n and p, we get lambda is equal to 2. In the first case, the probability that exactly 3 individuals suffer a bad reaction is given by P of R is equal to 3. Substituting the values in the probability mass function, we obtain e power minus 2 power 3 by 3 factorial, which simplifies to 0.1804. In the second case, the probability that more than 2 individuals suffer a bad reaction is given by P of R greater than 2. Direct calculation would require probabilities from 3 to 2000, which would be very lengthy. Therefore, we use the complement rule to write it as 1 minus P of R less than or equal to 2. This can be written as 1 minus P of R is equal to 0 plus P of R is equal to 1 plus P of R is equal to 2. Substituting these values in probability mass function, we obtain for R is equal to 0, it's e power minus 2, 2 power 0 by 0 factorial. For R is equal to 1, it's e power minus 2, 2 power 1 by 1 factorial. And for R is equal to 2, it's e power minus 2, 2 square by 2 factorial, which simplifies to 0.3235. In the third case, probability that none suffer a bad reaction is given by P of R is equal to 0. Substituting the values in probability mass function, we get e power minus 2, 2 power 0 by 0 factorial. It simplifies to 0.1353. In the fourth case, the probability that more than one individual suffers a bad reaction is given by P of R greater than 1. Direct calculation would require probabilities from 2 to 2000. So instead we use the complement rule and write it as 1 minus P of R less than or equal to 1, which is 1 minus P of R is equal to 0 plus P of R is equal to 1. Substituting the values in probability mass function, we obtain for R is equal to 0, e power minus 2, 2 power 0 by 0 factorial. For R is equal to 1, e power minus 2, 2 power 1 by 1 factorial. All these will be simplified to 0.5941. Consider the next question. A car hire firm has two cars which it hires out day by day. The demand for a car each day follows a Poisson distribution with mean 1.5. Here, mean is given as 1.5, and for a Poisson distribution, the mean is equal to lambda. In the first case, we need to find the proportion of days on which there is no demand, which is given by P of R is equal to 0. Substituting the values in the probability mass function, we get e power minus 1.5, 1.5 power 0 divided by 0 factorial, which simplifies to 0.2231. Converting this into the number of days, we multiply by 365, giving approximately 81 days in a year. In the second case, we need to find the proportion of days on which the demand is refused. As there are only two cars available, demand is refused if more than two customers arrive. Hence, this corresponds to P of R greater than 2. Direct calculation of P of R greater than 2 is not convenient since it involves an infinite range. Therefore, we use the complement rule and express it as 1 minus P of R less than or equal to 2, which simplifies to 1 minus P of R is equal to 0 plus P of R is equal to 1 plus P of R is equal to 2. Substituting the values in probability mass function, we obtain 1 minus, for R is equal to 0, it's e power minus 1.5, 1.5 power 0 by 0 factorial. For R is equal to 1, it's e power minus 1.5, 1.5 power 1 by 1 factorial. For R is equal to 2, it's e power minus 1.5, 1.5 power 2 by 2 factorial. All the terms simplify to 0.1912. Converting this into number of days by multiplying it with 365 gives approximately 70 days in a year. The next question is as follows. Average number of accidents on any day on a national highway is 1.6. Find the probability that number of accidents are at least 1 and at most 1. Again, the average, that is the mean value, is given, which will be lambda. Probability that the number of accidents are at least 1 is P of r greater than or equal to 1, which is 1 minus P of r equal to 0, that is total minus none. Substituting the value in the probability mass function, we get 1 minus e power minus 1.6, 1.6 power 0 by 0 factorial, which simplifies to 0.7981. Probability that the number of accidents are at most 1, that is maximum of one accident, is given by P of r less than or equal to 1, which will be P of r is equal to 0 plus P of r is equal to 1. Substitute these values in probability mass function and simplify to get 0.5249. In the next question, a manufacturer of cotter pins knows that 5% of his product is defective. Pins are sold in boxes of 100. He guarantees that not more than 10 pins will be defective. What is the probability that a box will fail to meet the guaranteed quality? Here we are asked to find the probability that the box will fail to meet the guaranteed quality. The guarantee is that not more than 10 pins will be defective in a box. So if more than 10 pins will be defective, the box fails to meet the guarantee. Since we are dealing with defective pins, we take the occurrence of defective pin as a success, which is given as P is equal to 5%, that will be 0.05. Total number of cotter pins in a box will be n is equal to 100. We know that the mean lambda is given by np. Substituting the values of n and p, we get lambda is equal to 5. The probability that a box fails to meet the guaranteed quality is the probability that more than 10 pins will be defective in a box, that is P of r greater than 10. Again, direct calculation would require summing probabilities from 11 to 100, which is very lengthy, so we use the complement rule and write it as 1 minus P of r less than or equal to 10. Substituting the values, we get 1 minus the sum of probabilities from r is equal to 0 to r is equal to 10. Substituting the values in probability mass function, we get the following expression. To calculate this using a calculator, we rewrite it in the summation form, which will be 1 minus, since e power minus 5 is a constant which can be taken outside, summation r is from 0 to 10, 5 power r by r factorial. The complete expression is simplified as 0.0137. Here comes the last question. If a random variable has a Poisson distribution such that P of 1 is equal to P of 2, the given condition is P of 1 is equal to P of 2. Substituting the values in probability mass function, for P of 1 we get e power minus lambda, lambda power 1 by 1 factorial, and for P of 2 we get e power minus lambda, lambda square by 2 factorial. E power minus lambda and lambda cancels both sides, and this simplifies to lambda is equal to 2, which is the mean of the distribution. In the second case, P of 4 is obtained by substituting r is equal to 4 in probability mass function. We get e power minus 2, 2 power 4 by 4 factorial, which simplifies to 0.0902. In the third case, we need to find P of 1 less than x less than 4. Since x is strictly greater than 1, we start from x is equal to 2, and it's strictly less than 4, so we go up to 3. Substituting the values in probability mass function, for x is equal to 2, we get e power minus 2, 2 square by 2 factorial. For x is equal to 3, we get e power minus 2, 2 cube by 3 factorial. And these terms simplify to 0.4511. Go ahead and solve the last part and share your results.